Okay, good day. This is dual enrollment pre-calculus. I am Mr. McCulley, and this is lesson 39, conic sections, the ellipse. Let's get to it. All right, so today we are going to write the equation of ellipse in standard form. We're going to find the eccentricities of ellipses, and we're going to use the properties of an ellipse to model and solve problems. So again, just as a review from the last lesson here, an ellipse, if the plane isn't perpendicular to the axis of the cone, it is called an ellipse. So our conic section, and again, we are sectioning a cone. That's how we get the term conic section. Um, and so the intersection of that cone and the plane is going to give us an ellipse. And another way to define the ellipse is to collect a set of all points in a plane. The sum of the distance from two fixed points is a constant. And again, so any place that you have a point on your ellipse, if you were to draw a line and measure the distance from, let's say it was this point here, from here to here, and from here to there would be the same as if you went from here to here plus from there to there. And that general equation is going to be, and I'm going to define it a little bit different on the other side because we do have a center of an ellipse. So just real quick, I would cancel that out and call that an x minus the h squared, and then we would cancel that out in x or y minus k squared. And we'll have that where h and k is the center. And so there are two types of ellipses. Just start talking about the points. The center of the ellipse is going to be that h and the k. The foci, the 2 points that you're measuring the constant distance to points on the ellipse, are going to be h plus c comma k and h minus c comma k for a horizontal ellipse. It'll be h k plus c and h k minus c for a vertical ellipse. In a horizontal ellipse where your major axis is horizontal, the wider axis is horizontal, um, your axis is going to be 2 times the length of A. And when I say this A right here, I'm talking about this value right here. And your minor axis is 2B, and this B very here is the distance along the minor axis. And so if we know some of these points, we can calculate A and B fairly easily. Now this C distance is the distance from the center to either foci. And so we can have two different types of ellipses, a horizontal ellipse and a vertical ellipse. When we talk about the horizontal and the vertical, the way that we tell the difference is that we have a value A being bigger than B. So the way I determine whether I have a horizontal axis ellipse or a vertical axis ellipse is I compare these two numbers underneath the x value and the y value. If the number under the x value is larger, we have something that looks like this, horizontal ellipse. If the value under the y minus k squared is larger, then we have a vertical axis ellipse. In both cases, the distance from the center to one of the vertices is going to be a squared minus b squared. And so we can use this to calculate parts if we are given parts that we don't know. So we are going to also talk about eccentricity, and eccentricity is kind of, for lack of a better word, the circleness of an ellipse. And so think of it this way: the closer to E 0 is, the more the ellipse looks like a circle. And so what that means is if you have, and basically what this is a measure of is the distance from the the eccentricity is a ratio of the distance from the center to, or excuse me, from the focus to the distance of along the major axis. So let's say we have a very circle-like looking ellipse. All right, that's not a very good ellipse, but if I were to do that, this is my major axis, this is my minor axis, and my foci would be very close to the center if it looks more like a circle. And so this distance that is A is going to be much smaller than the distance, oops, I screwed that up already. The distance we call to the foci is C, and the distance to the from the center to a vertex is A. and it's all the way over there. So C over A is going to be very small, closer to 0. Now, if we have a very ellipse-looking ellipse like this, if this is my center, then my foci are going to be way out there, and then my vertices will be way there. So this distance C right there, and this distance right here, A, well, if I go C over A, that value is going to be much closer to 1. So the closer E is to 0, the more the ellipse looks like a circle, and the more the eccentricity looks like 1, or the closer to 1, the more it's going to look like an oblong shape. So two quick examples here. It says find the equation of ellipse with vertices at 3, 1 and 3, 9, and the length of the minor axis of 6. Okay, so we can do that. Let's plot those points. And I think I want to move this down a little bit. And so let's make some values. 1, 2, 3. We'll go 3 there. 4, 5, 6 along the x-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. 1 right there. And so 3, 1 would be right there. And then 3, 9 would be right there. And so if these are the vertices, then I have a ellipse that looks probably something a little bit like that. We know it's not perfect, but that's all right. And that means that this distance right here is my major axis. So my A value is going to be under the y because I have a vertical axis ellipse. So it's going to be x minus h quantity squared over b squared plus y minus k quantity squared over a squared equal to 1. All right, so I got a squared, or a is going to be this distance right here. And since our vertical major axis is between these 2 points, all I got to really do is find the midpoint, and that'll be able to measure a. That's not too bad. And so if I go 1 plus 9 is 10. 10 divided by 2 would be 5. So my center is going to be at 3, 5, right? And if that's true, then the distance from 3, 5 to 3, 9, that's going to be 4. So I know that my A is equal to 4. All right. Well, they say that my minor axis right here is 6. Now, I don't have it drawn in very well because if it goes to 3, it should go to 0, and then it should also go to 6. But I didn't know that when I was drawing it in. Oh, I kind of did, but I didn't know how wide I would have drawn it. At any rate, if the entire distance is 6, then half of that, this distance right here, and I know I'm getting messy, would be 3. And so my B value is going to be 3. And since my center is 3 and 5, and my A value is 4, my B value is 3, I can come in here and just plug in and be done. So I'll have x minus the h, which would be 3, quantity squared, over, well, B is 3, so 3 squared would be 9, plus y minus k. Now my k value is 5, and then since a is 4, 4 squared is 16, that's going to be all over 1, and then we're done. All right, it says use the given equation to find the standard form of the ellipse, then list the center, the vertices, the foci, and the eccentricity of the ellipse. Okay, so we got a lot to do on this one. And I see, again, this is the general form. And I'm going to group the x's and the y's. All right, now I know that this thing is an ellipse. And the reason that I know it's an ellipse is because I have an x squared, I have a y squared, and we end up adding them. And then the coefficient for x squared and y squared are different. So we're going to kind of collect our x's and y's together. So I've got my 9x squared, and then I have minus 54x, and then I'm going to leave a little space, and I'm going to go 4y squared, I'll put a plus there, plus 40y, and then I'll leave a little space. And let's move the constant to the right and make it negative 37. All right, now I want to complete the square like I've done for a couple of the other ones in the previous lesson. But before I can do that, I'm going to have to factor out. I need this leading coefficient for both of these to be 1. So I'm going to factor out a 9 from the first two terms. And when I divide x squared, or 9x squared by 9, I get just x squared. And when I divide 54 by 9, I'm going to get 6x. All right, now if I factor out a 4, I'll have y squared plus 10y. And I haven't added anything yet, so we're going to leave that. And so let's say factor leading coefficient. So x squared and y squared have coefficient equal to 1. There we go. And so, and I still have negative 37 there. So I'm going to add, and well, let's do it this way. Let's say 37. We're going to complete the square. And we need to add b over 2 squared times leading coefficient. We need to add those to both sides. So I've got my 9, I've got my x squared, I got my minus 6x, and we'll put parenthesis there, plus 4. We got my y squared plus 10y, and then we have our minus 37. Okay. So I'm going to add half of that number squared. So half of negative 6 is 3, and we're going to add that, or negative 3, and we're going to add that squared. And we're going to add that to this side as well. So negative 3 squared. But because it's inside the parentheses, we have to distribute the 9 to both sides. Remember, we factored out a 9. And so that 9 has to be multiplied by all of those terms. So I have to multiply this side by, or this term by 9 as well. Similarly, I'm going to say half of 10 is 5, so I'm going to add 5 squared. But it's inside the parentheses, that's multiplied by 4. So when I come over here to add that, it'll be 4 times 5 squared. All right, so now I've completed the square. And so I'm going to write W-R-I-T-E as a perfect square. And so I've got 9, I've got x minus 3 quantity squared plus 4 times, let's see here, y plus 5 quantity squared equal to, okay, got negative 37. And so 3 squared is 9. 9 times 9 would be 81. And then 5 squared is 25 times 4 would be 100. So let's see here. I have, oops, I don't want that. Negative 37 plus 81 plus 100 equals, oh, why did I do that there? Dummy. Negative 37 plus 81 plus 100 equals 144. Okay, so let's see here. I get 144 right there. I get 9x minus 3 squared plus y plus 5 quantity squared. Excuse me. And so remember, if we go back to our equations, you'll notice that both of these are equal to 1 and there's no coefficients in front of our x minus h squared term or my y minus k squared term. And so what we're going to do here is, so that we can get that, we are going to divide both sides by 144, and it's this value here. And so I'll have 9 over x minus 3 quantity squared all over 144 plus 4 y minus 5 quantity squared all over 144. And then when I divide 144 by 144, I get 1. And so here I'm just going to simplify. 9 over 144 and 4 over 144. And so if I go 9 over 144 and I hit math, hit fraction, just to do it quick, I get 1/16. And so this thing will be x minus 3 quantity squared over 16. And then if I do the same for 1 divided by, or excuse me, 4 divided by 144, and I hit math and I hit fraction, I get 1 over 36. So this will be plus y minus 5 quantity squared over 36 all equal to 1. So I've done all that work here. Let's see here. Find the standard form of the ellipse right there. Standard form of the ellipse. Okay, what else do they want? Let's see here. List the center, the vertices, the foci, and the eccentricity. Okay, so the center is easy. The center will be, let's see here, 3, 5. Makes this positive and makes that positive, so we're good. And so since the 36 is under the y at 3, 5 on my x and my y axis, so I've got 5 there and 3 there. And let's see here, because a squared is equal to 36, we can conclude that a is just 6. So I need to go 6 above and 6 below to find my vertices. And so 6 above 3, 5 would be 3, and 5 and 6 would be 11. And then 6 below would be right here, would be 3, negative 1. And I need to find my focus, my foci, and my foci are c units away. So from here to there, and then this distance right there, and then this distance right there are both c, not 6. Come on. That's c and that's c. So I can figure out what c is. Now, how do I find c? Now remember here, c squared is equal to a squared minus b squared. So I have all that information. I know that my a squared is 36, my b squared is 16. So let's add some space. C squared equals a squared minus b squared. So c squared equals 36 minus 16. C squared, that means c squared is equal to, not 40. Come on, Macaulay, add. 36 minus 16 is 20. So c equals the square root of 20, which would be 2 square root of 5. Because let's just do it. C equal to square root of 20, which would be square root of 4 times 5, which would be 2 square root of 5, which is what I have there. So my foci are going to be, and again, we're going up and down, so we're adding to the y. It'll be 3 comma 5 plus 2 square root of 5, and those aren't like terms, so I can't combine them. And 3, 5 minus 2 square root of 5. Now you could guesstimate what those things are. And then the eccentricity, how did I spell that? ECCEN, and we'll just put ECCEN, we'll abbreviate, is going to be, let's see here, it'll be 2 square root of 5 over, what did I say, 6? That's my A. So it'll be square root of 5 over to 3. So what is square root of 5 over 3? Square root 5 divided by 3 is 0.74. So, or 0.74, let's go 3 places, 475. And so if I were to make a statement about this thing is more ellipse-like than it is circle-like. So I have answered all of those particular questions. And that's all I've got for today, folks. So, the Star Wars fun fact of the day: every clone trooper in episode 3, Revenge of the Sith, is completely CGI. No clone or stormtrooper costumes were made for that movie. And there's pictures of all of the ones that you see there. Well, that's all I got for today, folks. Have a great day. See you in class. Bye.